Okay guys, so we're doing rational functions again. So this time we're dividing rational expressions. So first we'll do this one right here. Okay, so there are two over here times 2, 3x. So although this is categorized as precalculus, you should be very familiar with this if you are at this level, okay? So you can get rid of this, and this becomes 2, no, sorry, 4x to the power of 2 and divide by 5, right? So this is our answer. Moving on to this one. So if you have a divide, then it's gonna be reversed n times, right? Reverse it and multiply. So the numerator will become 4, denominator will become numerator, and you can do this, and this become 8, and 7 times 5 equals 35. Okay? Okay, then let's look at the answer here, which is 8 over 35. Okay? Okay, how about the domain? The domain is the original, right? You have to check for your original calculation. I mean, terms. Original terms are 6x to the cube and over 5 times 2 over 3x, right? So your 3x, your x cannot be 0, otherwise this will be undefined. So you have to look at your original terms. And same thing with here. Um, so originally you have divide. Um, you don't have any problems here, but since this will change the denominator to numerator and numerator to denominator and multiply, you cannot multiply an undefined number, right? So this will be 5x cannot be 0, x cannot be 0 again, right? That's your domain. Okay, let's move on to multiplication of rational functions. Okay, so now you have this. You're gonna factor it if you can, right? So this will become x plus 3, x minus 3. Oh, sorry. Is there a ruler? Okay, no, that's okay. And this will be x minus 5 square, right? And not equal. Okay. So here we have 4x minus 20. 4x minus 20 times 4x minus 20. You take the 4 out, so that will be 4 minus 5, x minus 5, and this will be 2 and 3, right? 2 and 3, and they are all plus. x plus 2 and x plus 3, and you cancel out the x plus 3 and cancel out one of the x minus 5. So you're left with 4x minus 3, x minus 5 times x plus 2. Of course, you can expand this, but if it's not required, in the test, then don't bother, right? Okay, that will be our answer here, right? Exactly the same. Okay, why couldn't it be minus 3? So you have to look at your original graph here. So the domain cannot be what? X cannot be 5 because originally there's a 5 here, right? In the denominator. And originally there's a minus 2 here and there's a minus 3 here. So these three numbers cannot be in our domain. Okay, so let's move on to dividing rational functions, expressions. Okay, dividing rational expressions here. We have expressions here. So let's just factor it, okay? So 4, 1, I'm guessing, and 1 plus 1, right? And over what? You take the minus 3 out, x plus 5. Okay, divide, so reverse it. So your x plus 4 and x minus 4 will be underneath, right? And this will be up, which is 5 and 6. So minus is the 6, plus it's the 5. Okay, so now you can cancel, right? Do your canceling. Cancel, cancel, and you got what? X plus 1, x minus 6, and minus 3, x plus 4. So what about your domain? We cannot tolerate uh, that denominators are 0. We cannot calculate the undefined numbers, right? So we have negative 5 again, and negative 4 and 4, right? Negative 4 and 4. Okay, so what's our answer here? So x plus 1, x minus 6, right? Minus 3, 8. So this one is already canceled, so we make a correction here. It's canceled right here. It's canceled right here and here, right? So there's nothing here. Um, so negative 4. So 4 numbers cannot be included, right? So that's the division. Not only do you have to look at the original terms to find out your undefined numbers, which is in the denominators, you also have to look into the multiplication that you're doing your calculation with, right? It also cannot be undefined during your calculation, so these numbers cannot be zeros as well. So you got 4 numbers in this case. Okay, thank you for watching and good luck on your test. Thank you.